In this video, we are going to review the concepts from Chapter 3 to get ready for the test. First, we looked at adding or subtracting rational expressions. Now, to add and subtract rational expressions, the first thing you have to do is get common denominators. So we're going to multiply by x plus 1 over here and x minus 2 over here. Now, once we distribute these to both terms on both sides, over here we'll have 3x plus 3, and over here we'll have minus 2x squared minus 4x. Our denominator will just be x minus 2, x plus 1. And then if we simplify here, this is 3x plus 3 minus 2x squared plus 4x all over x minus 2, x plus 1. Now if I combine my like terms, I get minus 2x squared. I have two x's, 3x and 4x, which gives me a plus 7x, and then plus 3. And then that is going to give me x minus 2 and x plus 1. Now I cannot factor that and simplify it anymore. So there's my answer. So the next one, do long division. So if we do long division, this is 3x minus 2 is outside because that's on the bottom. And then we divide that into 6x squared plus 5x minus 13. And so we think, what times 3x gives me 6x squared? And that would be 2x. So I take 2x times 3x, and that gives me 6x squared. 2x times negative 2 gives me minus 4x. When I subtract, I change both of my signs, and then this gives me 9x minus 13. What times 3x gives me 9x? That is plus 3. So then this gives me 9x minus 6. Change both my signs, minus plus, and this is going to give me negative 7. So when I divide, I get 2x plus 3, and we're just going to write that as a remainder of negative 7. If we want to divide with synthetic division, we first have to decide what number goes in the box. And if we're dividing by x minus 3, 3 goes in the box. We have 1, negative 4, 6, negative 3. Remember, if you're missing any terms, if you're missing an x or an x squared, you have to add a 0. So we drop the 1. 3 times 1 is 3. We write it here. Then we add, which gives us negative 1. Then we multiply. 3 times negative 1 is negative 3. Then we add, which is a positive 3. 3 times 3 is 9. We write here. Then we add, and we get 6. And so then our answer is 1x squared minus x plus 3, and our remainder is 6. Let's look at the next one. Is x plus 2 a factor? Well, the way we can determine that is to do synthetic division, and c is our remainder 0. So we can drop the 1, multiply, add, multiply, add, multiply, and get 0. So this is our remainder. It is 0, so the answer is yes. X plus 2 is a factor. Now, the other way you could have done that would be to think of that polynomial up there and to substitute in negative 2. This would be our remainder theorem. So this would be negative 2 cubed plus 9, negative 2 squared, plus 13, negative 2, minus 2. And if we did that, since we already know it's a factor, you would get 0, which would also tell us the same thing. Now, you would never do both of those methods. You would just pick one, either synthetic division or plugging in -2. Both of them would give you 0. Both of them tell you your remainder is 0. So yes, it is a factor. So given a function and x plus 2 is a factor, find all zeros. Now, the important thing is we want to do this without necessarily using our calculator. If you did graph this on your calculator, you would see that -2 is the only zero, the only root, the only x-intercept. So I'm going to do synthetic division. We need a 0 because there's no x squared term. So we drop the 1, we multiply, we add, we multiply, we add, we multiply. So we get 0, which is good since we're told that it is a factor. And so we're left with x squared minus 2x minus 2. Well, to solve that, we're going to need to use the quadratic formula. So the quadratic formula is minus b plus or minus b squared minus 4ac all over 2a. So this just becomes 2 plus or minus square root of -4 over 2. And the square root of a -4 is a 2i over 2. So then this simplifies to 1 plus or minus I. So our zeros are -2. That's the one we got from the factor. And then from the quadratic formula, we get 1 plus I, and we get 1 minus I. So there are our zeros. Make sure you understand the difference between the roots and zeros versus the factors and answer the correct question. So another one that kind of looks into that. Find the quadratic function with integral coefficients with a root of 2 plus 3i. Well, by our conjugate root theorem, if 2 plus 3i is a root, then 2 minus 3i is also a root. So if those are the roots, our factors are x minus 2 plus 3i and x minus 2 minus 3i. Now, the first thing we're going to do is distribute inside those parentheses so we only have one set. And then what we're going to do is take the first x and multiply it times all 3. And that would be x squared minus 2x plus 3xi. Then we're going to take the -2 times all 3. And that's going to be minus 2x plus 4 minus 6i. And finally, we're going to take this times all 3, and that's going to be minus 3xi plus 6i minus 9i squared. Now, as with all of these problems, the terms with the i's cancel out. It's a way to tell if you're doing it correctly. The -9i squared, remember I squared is -1, so this is -9 times -1, so this just becomes a plus 9. So I have x squared, I have 2 x terms, so minus 4x. I have 4 and 9, so I get plus 13. So there is my quadratic that has the roots 2 plus 3i and 2 minus 3i. Next problem. Use a calculator to find all zeros and local max and mins. So if I graph this on the calculator, this is what the graph is going to look like. So it looks like that. So first off, there is my minimum. Now let's show how we can find that minimum by finding the maximum. So to find that, we will go to second, calculate. And if I want to find a maximum, I go to the maximum. I move my cursor as close to the maximum as I can. And then I go right, or excuse me, left, enter. Then I go right, enter. And then I go back to the peak and hit enter. And I find my maximum. So you can see what I find is my max is negative 1.53, 7.13. My min is 1.53 and negative 7.13. I also need to find my zeros. And if you do the same type of thing, the left and right, you get 1 0 to be 0. And then you get negative 2.65 and a positive 2.65. And let me just show you how to do that. If I want to find the 0, I go to second trace and I go to 0. Once again, we move the cursor close to the 0 or the x-intercept. We go to the left, a couple clicks, hit enter. The right, go back to the point, right a couple clicks, hit enter. And then hit enter a third time, and you can see we get the negative 2.65. Let's talk about the x and y intercepts. Now, to find the x-intercept, you let y be 0. Now, the only way y can be 0 is if the top of the fraction could be 0. So we just look at the top, and we set that equal to 0, and we get 1/3. So 1/3 is my x-intercept. For my y-intercept, x is 0. So I plug in 0 for x, and 0 times anything is 0. So what happens is these kind of get erased, and I get negative 1 over negative 1, which is 1. So my x-intercept is 1/3. My y-intercept is 1. Now it also asks here for the asymptotes. And we have two types. We have a vertical asymptote. And the vertical asymptote is where the bottom is 0. So we have 2x minus 1 is 0. So we get x is 1/2. Now we have to check. If that number also makes the top equal to 0, we do not have a vertical asymptote. But in this case, it doesn't. So there's our vertical. To find our horizontal asymptote, we take the bottom and we do long division into the top. So what times 2 gives me 3? So what times 2 gives me 3? It's 3/2. So 3/2 times 2, the 2's would cancel and give me 3x minus 3/2. We change our signs to subtract, and we get 1/2. But the important part, our horizontal asymptote is 3/2. And those are hard to get from the calculator because they're fractions. So that's why we want to make sure we understand how to do those without using the calculator. The final question is one of our maxim and mins and volume or area questions. So suppose you have 100 feet of fencing to make a rectangular dog pen divided into 2 equal sections, and you want to use the house as one side. So what we're going to need here is we need fencing for this side, the middle divide, and this side, and that side. So this is a little different from other ones because we not only have x on this side and x on this side, we also have x in the middle, which means this final side will be 100 minus 3x. So our area is going to be x times 100 minus 3x. our domain is we have to be bigger than 0, and the biggest it can be is 100 divided by 3. So if we wanted to go decimals, if we got bigger than 100 divided by 3, 33 1/3, that's going to make that negative. So we could just say 33.3 repeating is our domain. Now, find the dimensions that give you the maximum area. So if we go in and we graph this, x 100 minus 3x. And to help us out, I'm going to change my window from 0. Let's go to like 40, since it's a little bigger than 33. If I graph that, can't really see the top, so I'm going to hit trace, and I'm up around 800 or so. So that tells me to make this a little bit higher. Let's make this like 1500. So there I can see my max. Now I calculate the maximum. I go to the left of the max, the right of the max, I guess, and I get 16 2/3, 833. Now, the question is, what dimensions give the maximum area? Well, if this 16.666 is actually 50 over 3. So that means x is 50 over 3. If I then take that number and I substitute it in for this x, it gives me 50. So my dimensions are 50 over 3 by 50, or 16.67 times 50. All right, those are all of the problems that were on the review sheet to get you ready for the test over Chapter 3. If you can do all of those problems, understand how to do those various problems, you should have no problem on the test.